Hello, good morning, Year 11. So today we've got a lesson on work done and energy transfers. Let's begin again, like always, sorry about the same format, with our kit quiz. So 1 to 5 on the mini whiteboard. And then what you need to do is come up with the key term that matches this definition. You might want to pause the video now for 3 minutes. And these ones should be quite quick ones. Pause the video and then resume when you're ready. Okay, so let's look at these answers then. So number 1, how easily a liquid flows is viscosity. Number 2, the distance a car travels while the driver reacts. So that's the thinking distance. Number 3, the sum of thinking distance and braking distance. That's stopping distance. Number 4, a single force replacing a number of forces acting upon an object. The resultant force. And lastly then 5, Hooke's law is F equals KE. Okay then, so mark that 5 and we'll get started with our lesson. So you may need to transfer to your exercise book now. So like I said, our lesson today is on work done and energy transfer. And our learning objectives today are to describe the energy transfer involved when work is done. So we'll find out what that concept means when we say when work is done. Convert between Newton meters and joules, and then apply and recall the equation work done equals force times distance. So let's look at this concept of work done. So whenever you push an object, so if, for example, I was having to move a table in the classroom, I would have to put some force into moving that table, and it would depend on how far I had to push that table as to how much work is done. And work done is essentially how much energy do you need to move something a distance, and how much force do you have to put into doing that. So this definition to put on a revision card then is when a force causes an object to move through a distance. So I could be moving a table, I could be rearranging furniture in my house, and I could be pushing furniture around, moving a bed, changing the order of the room or whatever. So you're pushing an item, and that means then work is done on the object. And then because that object is moving from a starting point to an end point, you've got displacement of an object. So here's the equation then. So to work out work done, which is measured in joules, obviously linked to energy, work done equals force times distance. And what can be a little bit confusing is that the symbol for distance is an S. And people do find that a little bit confusing. So W, work done, equals F, force, times distance with the S. So some people do get a little bit confused with that S, but S is the symbol for distance. And you can see in the orange box there, we've got symbols in units. So work done, W, in joules, J, and then force in a capital F is measured in newtons with a capital N, and then distance with the symbol S has got the unit meters with a little m. Okay, so here's a fact then, that 1 joule equals 1 Newton meter. So it takes 1 joule of energy to apply a force of 1 Newton to move an object 1 meter. So 1, 1, 1. It takes 1 joule of energy to move an object 1 meter using 1 Newton of force. Okay, so obviously that's a relationship that you could magnify there. So you could say 2 joules equals 2 Newton meters, 20 equals 20, etc., etc. And this information would be key to have on a revision card. So you can pause the video and make yourself a revision card, because remember, there is still going to be some form of assessment when you come back to lessons, when hopefully lots of the population have been vaccinated and it's safe to come back to school, so that we can decide what grade we'll be entering for your Year 11 exams. So I like to use a triangle when I'm doing equations because it just helps me rearrange the equation. So for example, if I was trying to work out force, I would do force equals W divided by S. So force equals work done divided by distance. If I was trying to work out the distance, I would be doing S equals W divided by F. Okay, and again, that would be important information to have on a revision card. So let's do an example together. So this little animated character is trying to pull the weight up, and they're going to try and pull it by a distance of 5 meters. So they want to pull it 5 meters upwards, and it's going to take a force of 10 newtons to do so. So remember, the equation for work done is force times distance. So you would simply do 10 times 5, and it would equal 50 joules, because we must remember to include the unit. So the layout that you can see there in bold, so W equals F times S, you're showing the examiner when you write these things out like this, that you know the formula that you need to use. And then we put in the numbers that we need to multiply together. So you're getting that from the question. And then we've got the final answer with the unit. So that is the layout for how we should be working out our equations, showing our working, and then giving our final answer with the unit. So here are some practice questions for you to use and for you to have a go at. So for each one, remember, write out the equation that you would need to use, write out the numbers you're going to use, and then the final answer. So each question should occupy 3 lines in your book. Okay, so there's 5 questions, 3 lines each. So 3 times 5 is 15 lines. That's how much work I should see in your exercise books. So stop the video now, work out all of these calculations, and then we'll go through the answers. So make sure you pause the video. Okay, let's go through the answers. So for the first one, to work out work done, we do force times distance, which is 600 newtons times 1.6 meters. And for this one, you had to work out that distance. So because they climbed 20 steps and each step was 0.08 meters, you then had to do 20 times 0.08 to work out the total distance. So then you get a final answer for work done of 960 joules. Next one, then number 2, we get a final answer of 84 joules because we do 70 newtons, that's the force, times the distance of 1.2. That was how far the object was moved or displaced. And we get a final answer of 84 joules. Question 3, you can see the answer is 4 joules. Now it's important to note for this one that in the question, they specified 20 centimeters, but actually you should know that you have to convert into meters. So you would divide by 100 because there's 100 centimeters in 1 meter. So 20 centimeters is actually 0.20 meters, and we get the final answer of 4 joules. This time, the student weighing 900 newtons climbed 60 steps to a biology lab. So coincidentally, the school that I went to when I was younger had 3 floors for the science department, and you had to run up a lot of steps to get to the top labs. So 60 steps times by 0.08 to get the total distance of 4.8 meters. Okay, and then you do 900 times by 4.8 and you get the final answer of 4,320 joules. And then the last one then should be quite straightforward. 110 newtons times by 2 meters, you get a final answer of 220 joules. And each one of these would be worth 3 marks. So again, we should have a total number of marks out of 15. So in your book, when you send me the picture of your work, I should see a mark out of 15. So 3 marks for each one. And make sure you include the unit as well. So I should be seeing purple pen, ticks, ticks, ticks in your books, or any corrections you need to make in purple pen, and then a mark out of 15. Okay then, so any object that is sort of, imagine it to be sort of scraping across the floor, there will be some friction. And because of the friction, because you've got a contact force, there'll always be some heat given off from that object moving to its surroundings. So if you were just right now to rub your hands together, like I'm doing, as you rub your hands together, you should feel that your hand is getting warmer, because when you have moving objects moving against each other, you have friction, and from that there's a release of sort of thermal energy. So a force doing work often causes a rise in temperature as energy is dissipated to the thermal energy stores. Basically, anything that's moving against something else will transfer thermal energy to the environment. And this is not good. This is wasteful. It makes the energy transfer inefficient. And you can reduce it. So you can do things like lubricate and use oils and things to make things more slippery so that when they do move against each other, there's less friction. So it's not a good process. And at this point, we should just recap from a topic in year 10, the energy topic, that the equation for efficiency, to work it out as a percentage, is you work out how much useful energy has come out of an appliance and divide that by the total energy in. So if, for example, we've got a hairdryer, we know that we plug our hairdryer in and it's got an input energy of electrical, and then you're using your hairdryer, and obviously the purpose of that is to get thermal energy to dry your hair, but it makes a loud noise, and so you have a waste of sound energy. And so the higher the percentage, the more efficient the device. And so this would be a good thing to practice. So here's an exam question then. So for the first one, you need to do a bit of applying from the question. Okay, and then for the second one, you actually need to use the equation that we were using earlier. So this question is out of 3 marks. So pause the video for 3 minutes, have a go. You can do this on your mini whiteboard or in your exercise book. And then in 3 minutes, we'll go through the answers. Okay, so first of all then, the first one was just applied from the question. So later in the journey, the bus is moving and has 500,000 joules of kinetic energy. The brakes are applied and the bus stops. How much work is needed to stop the bus? It's exactly the same. So it's the exact same of how much energy it had when it was moving. Because remember, the rule about energy is that it cannot be created or destroyed, it can only be transferred. So all of that kinetic energy would be transferred into stopping the bus. Then for the calculation for the second one, the bus stopped in a distance of 25 metres. That sounds quite worrying, to be honest, but we'll come back to that in a future topic. Calculate the force that was needed to stop the bus. So for force, we're going to do work done divided by the distance. So we know from the first question that the work done is 500,000. You divide that by 25, and you should get a final answer of 20,000 newtons. So if you've got 20,000 newtons, then that's worth 2 marks. So we were doing 500,000 divided by the distance of 25, and that's how we work it out as 20,000 newtons. So for that one, you might have used the triangle and you're rearranging the equation to work out force, because force equals work done divided by distance. Okay, so that's the end of the lesson. Please make sure you use the additional links on Google Classroom to practice, and also you need to send me a picture of your work now, please, so that I can just check to see how you're getting on with it. Thank you. Have a good day.